Researchers from China have come up with a new method to do hallucination correction for multimodal large language models. This method they have titled it as Woodpecker. So just like how Woodpecker heals trees, this model picks out and corrects hallucinations from generated text. So this is an image over here, and you are asking the multi-modal model to actually explain this image. Please describe this image in detail. It says this image features a cute red dog running across a grassy field. Around the dog, there are several other dogs. So, this is hallucination. Red is hallucination. It's not red colored dog. Several other dogs are not present over here. So, how does Woodpecker work? It consists of 5 stages: key concept extraction, question formulation, visual knowledge validation, visual claim generation, and hallucination correction. And this is a training free method. It is used as a post remedy for correcting hallucination from multi-modal models. So here is the process. Okay. So what happens is that given this as an input image and the queries describe this image, uh, the output of a multi-modal language model is the scene takes place in urban area. Bicycle is parked next to trash bin. The cycle is situated in the right side of the image. Front wheel slightly turned. There are several other people in this area. There are no people, right? So the first stage is key concept extraction. So for key concept extraction, they take this input and give it to a large language model. So large language model they used over here is ChatGPT 3.5 Turbo. So using a particular prompt, they extract the key concepts. Okay. Then based on the key concepts, they create questions. Right? How many bicycles are there in the image? What is the next to trash bin? Where is the trash bin located? So based on the key concepts, they create questions. Then they use a visual question answering model to get, to answer these questions based on the input image. So that is how they create a visual knowledge validation. Then based on the visual knowledge, so the visual knowledge is a bicycle is present over here, the bounding box, a recycle bin in the front of the building. So they generate visual knowledge. From the visual knowledge, they do a visual claim generation, which confirms that yeah, this bicycle is present, the bicycle is present here, and the bounding box, there are 2 trash bins. This is an object level. Okay. Similarly, you can have an attribute level for the objects. For the trash bin, a recycling bin is next to the trash bin, right? A trash bin 2, a recycling bin is next. Bicycle is also next to the trash bin. Now, based on these visual claims, the LLM can finally generate the response by editing this response, right? And remove the hallucination and show the evidence in the form of bounding boxes over here. So that is the idea. The final step where hallucination correction is done. So this is very clever way of making use of an LLM, a visual question answering model, to actually remove hallucination from multi-modal models. Okay. The other way of the traditional way of removing hallucination is further instruction tuning and training. Okay. This is a post-training method. It doesn't require training as such. You are using already available algorithms or models, and then you are dividing it into these stages to improve or remove hallucination. That's the key idea over here. So some more details are present, like how, as I said, they make use an LLM for key concept extraction, right? For question formulation also, they use a prompt to generate questions based on the key concepts which have been extracted. It could be questions like, is there any object in the image? How many objects are there? Or it could be questions like, what is the object doing? On the right side, position based question, those kind of questions, right? These are free form formulations of questions which are given to the LLM, right? uh, Basically based on the concepts, the prompt is given which will generate these questions using the LLM. Okay, for visual knowledge validation, they make use of an object detector to find out objects are present or not. And for attribute level question, how many objects and other questions which have been generated over here, they make use of a visual question answering model. Then the visual claim generation happens. It could be object level claims, right? So that is used for object level hallucinations. So it could be like how many objects are present, right? Is that there is no object present, things like that for non-existent objects, right? For attribute level claims, it's about what are the attribute of the object. It could be position, colors, action, etc. And then hallucination correction is done by combining the visual knowledge base with the original responses into a prompt. They instruct an LLM. So what models did they use for this experiment, right? How did they do this, right? What was their setup? Okay. So for the implementation, as I said before, Chat GPT 3.5 is your LLM. Okay. Which is used for tasks like key concept extraction, question formulation, hallucination correction. Okay. For open set object detection, they make use of grounding dyno to extract object counting information with default detection thresholds. They use blip2 flan t5xsl as the VXA model, visual question answering model. That is the answer. Okay. So with these, combination of these three models, GPT 3.5 Turbo, grounding dyno, and blip2 flan t5xsl, they can perform these stages and they can do hallucination correction for various multi-model large language models. Okay. So the baseline models are Lava. So these are all your multi-model large language models. So that is what they use for generating the responses, and then they correct it using this framework. So this is a pretty interesting method, and what they say is that on a particular benchmark, the results improve by as much as 30% on the POPE benchmark. Okay, a 30.66, 24.33% improvement in accuracy over the baseline mini GPT or this mplug all methods, or multi-model large language models. Okay, over that it achieves this kind of an improvement. So this is a pretty clever way of removing hallucinations in a post-processing fashion without any training. So here are some examples of how hallucination has been removed. So there is this image, and say describe this image. The image features a young boy riding a cycle on a dirt road. There are several other people. There are no people present over here. So this is how they correct it, and it comes like the image features a boy, bounding box, riding a bicycle, bounding box, road, bounding box. There are no people or object in bicycles in the image. So that is how hallucination is removed over here. Many such examples are present over here, so you can check it out. The various prompts at each stages are also quite interesting over here. You can check out the prompts, and these prompts can be used in isolation also. For example, if you want to do a good key concept extraction, probably you can just look at this prompt and use it with ChatGPT for just key concept extraction. Or you want a prompt for question formulation based on images, based on this thing, not the image, based on the output, based on the key concepts. You can look at this prompt which is present in the appendix over here. So it is interesting in many ways over here. So this is a short video on Woodpecker. Woodpecker is a framework or a method for removing hallucination in the text which is generated from multi-modal large language models. So I would put a link to this paper. I hope this video is useful to you. If you like the video, please like, share, subscribe to the channel. See you in another video.